Okay, so okay, so
What the heck? Oh, sorry.
okay, so
What the heck? Oh, sorry.
okay, so
What the heck?
so I got this kind of working for part two. You know, it's printing something, but then I like flipped through like 1,000 of them and decided this is like annoying, and I'm not gonna flip through 1,000 more. So I was thinking about this a little bit, and after I rage quit, after that I got a new plan. So I think I'm gonna try to like look for pictures that are statistical outliers. Okay, so like look at all the random. We'll look at all the values of x, and they are pretty random. You know, it should be like a pretty even distribution, right? And then we'll look at the values y. It should be pretty even. And then, you know, hopefully if we flip through a bunch of different pictures, one of them is going to have like a very not random distribution. And that will be our answer. So we'll try to see. And we'll see if I can code this up. And then we'll give that a go. And then we'll see if this has any success. And if not, then I'm really going to pull my hair out and quit this, I think, or something, or come back to it later. So I don't remember how to do all this stuff. Variants. So I am asking Chat GPT how to do it in a different window, and I'm not considering this cheating because, like, you know, there's probably some way to do this already in Prolog, and I just don't know what it is because I'm new to Prolog, right? So we're just going to look at the variance of everything, and we're going to start getting some numbers, sample numbers, and we'll kind of get a sense of what they should be. So at least I do know how to do. You know, actually, I'll tell you this. I'll copy and paste what little help Chat GPT gave me. Okay. Oh geez, where the heck's the formatting, huh? I actually told it I want standard deviation, and I don't know if I don't really know. Do I want standard deviation or not? I think, or do I just want variance? I think just variance is okay for right now, right? So let's say, right, sum list, huh? No. Okay. So we're gonna make this actually work. Actually do what we want. So, let's say. So I guess if we want, we gotta get the like mean. Okay, variance is the mean. What is the formula for variance? Deviation square. What the heck is a deviation square? Number times mean. Okay, you know what? We will take your help, ChatGPT, but we're not gonna do things this way. Where's my syntax highlighting, huh? We're gonna improve the code a little bit. Okay, sum list. We don't have sum lists. I think they gave me that, but I'll just write it myself. That's not how, the way they told me to write it is not how I read it anyway. So we'll say like mean x robots. And we'll do aggregate. No, mean. Yeah, we'll sum them all up. Sum of x. Robots. Total. And we actually want to destructure on position. Get x. We don't care about y. And we definitely don't care about velocity. So that should give us the x. Sum of all x for all the robots, you know. And then, that's our sum list. Length of lists. Yeah. Length is on, and the mean. We will call this sum. And we will call this length, okay? We're using CLPFD, constraint logic programming over finite domains, instead of like the lower level is, just out of habit. I guess it shouldn't matter since it doesn't need to like solve for these using constraints. But we'll do it that way, okay. Now, let's see if we could get like the mean values of x for my robots. Okay, so we'll do example, yeah, robots, and then are you talking about? What do you mean it doesn't exist? It's literally right here. It's literally right here. What the heck are you talking about? Don't try to play me, thing. What? Sum of x, length, robots. Sum divided by length. Let's try that. We got our robots. Mean x. Aggregate. Get the sum of x for every member, every robot, all the robots. Aggregate them all. Oh, oops. This should have been aggregate all. Okay. And then we said mean supposed to be sum divided by length. No, is that what I did wrong? Okay. So it's sum divided by length, right? Sum. No. Divided by length. Okay. What in the heck's happening? What the heck? I think it's not loading my changes. I think this is the part where I restart Emacs. Sometimes it just gets in this weird state where it does really crazy shit, and I cannot understand why it's doing it. And it just does not like stops like reloading things correctly, and I don't know what the heck, but okay. Robots, example, robots, x. Yeah, okay. There we go. Mean x is in a, what the heck? How could it be a range? What the heck? Mean, sum, what? Oh, mean is sum divided by length. There we go. Yeah, okay. The mean value is x. Oh, you know what? We do need to use floating point math here, don't we? Okay. So, should not use integer math. And we wanted aggregate all. Right? Okay, so that's the mean x for this list of robots. Okay, let's do the same thing for y. Probably a way I could combine these both into like share more code between these rules, but we're just doing some experimental coding at this point, you know. So okay, now what's the next step of calculating variance? Okay, we got the mean. Variance. Mean. Got the mean x. We'll call this variance x. I'm just gonna copy this stuff right now. It's fine. Sum list. I don't have sum list, okay? Sum, we'll do. Why are we calculating sum twice, right? Mean. We'll just have this return this sum, huh? Sum of squares. Oh, never mind. Returning the sum is of no value to us. We do need sum of squares, so I'll just do this. Sum of x this point we're desperate. You know, we'll try anything at this point, right? Variance X. Okay. Variance X. What is a function? Deviation square 3 square. What the p? It's not a function. What? Squared. Is it saying this is not a function? Well, we could probably, No, that does work. Okay. So what the heck you talk? What's not a function here? Deviation square, arithmetic. P zero is not. Man, I'm hella confused. What are you talking about? P zero. I don't see any P's. I don't see any predicate. Variety zero even. Do I have a duplicate deviation square in here somewhere? Okay, let's try this. Let's just see if I'm just being dumb. What? Man, there has to be some way to do this stuff already in some Prolog library, so I'm wasting my time trying to figure out how to write variants and stuff like that, but whatever. Okay. Deviation squared P is not a function. Okay. What the heck are you talking about? Where? Make sure it's actually like loading my changes and we're talking about the same thing. Yeah, okay. What's not a function then? Square is number plus mean. That looks fun to me. 100. Square is 100. Okay. You don't like this, huh? What did I do to deserve this? P zero is not 100. Okay. Oh. There we go. Okay. Number is not a number. Duh. Okay. Deviation squared robots. Oh. Okay. Deviation square mean number. Yeah. Robot X. Let me go to destructure robot. X. Yeah, is that good? Mean, what the heck? Mean. Okay, we gotta capture mean. Okay, mean X, blah, 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 blah. Okay, I think that should maybe fix our variance for X. Okay, I'll just do the same thing for Y. This code is sloppy, and I should, extract variance out to a separate function, blah, 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 whatever. But I don't have time for that because I don't even know if this is going to work. So we're doing it sloppy now, and we'll see if we could even make anything happen. And if it does, then, then we'll go back and clean it up later. Maybe. Okay, so we got variance X. Okay, so I think an outlier would have like less variance, right? You know, these instead of being just like a random bunch of crap, the variance would probably be pretty low. So I think I'll just sum variance of x and y together up, and then we'll use that as our variance-ness number, and then we'll try to get a sense of what the range of those should be, and then we'll try to find ones that are way out of that range. So variance-ness is what we're going to call it today, okay? I just don't care anymore at this point, you know. But this problem broke me, so sometimes you just gotta do exploratory coding, you know. Variance in this. Okay, so we're gonna do a new thing. We're gonna print the robots, and we're gonna print out the variance-ness, and then we'll try to get just a like rough sense of some of these different answers. Yeah, that should do it. Okay. Let's do this. N is in 0 to like, I don't know, 20. Print robots. And I changed this earlier to take a input stream. So I think what standard out call is called like user out or something. What the heck is it called? Current out? No, is that what it's called? Output? That was called user output. It's like standard out, right? That's not it. Is that it? Why is it? I think current out is fine because current output should be. Let's see if that works. Okay, and then we'll do okay. Uh-oh, where the heck is it printing it? Okay. This is a question for ChatGPT or something, or Google. Give me 1 second while I look this up, unless someone wants to tell me what it is. Yep. I had looked this up earlier, so. Stream aliases. Oh my god, it is user output. Well, thanks a lot. Autocomplete. Why are we not? Is it user? What the heck? Why is nothing being printed, huh? Am I on crack? Print robots. Right there. I mean, this should theoretically be getting written to it. Oh. Stream. Oh. I'm dumb. Okay, never mind. We want print robots in. That's why. Stream, input, we want example. And in. Okay, so these all have like values. Okay. Let's try to look at the like real input. Oh man, what the heck? Maybe we don't need to actually print anything for right now. I think it's probably just enough just to print the variance-ness. Okay, so these all have like, wow, these are all really consistent, aren't they? So they're all like 1600 or above. So let's make V. Oh, you know what? We didn't even need to print out V. We could just have V come back as like a something that we solve for, right? So, and then now we can solve for a v of a certain value. So we can try this again. So let's load it. Yeah, okay. Nice. We don't even need to print v anymore, so okay, so now let's say v has to be, let's look for values of v that are like less than like, I don't know, like 1500 maybe. Might be something promising. Oops, let's use let's say actually we'll give this a range, v's and 0 to we gotta convert. I can't use integer constraint logic programming over the integer domain here. You gotta say v is like less than 1500. Find me a freaking answer for v, please. V is, oh, duh. Well, what the heck? We just printed. Oh, don't need to print all these new lines, huh? So we didn't find anything in the first 20, right? So let's try like, I don't know, like 1,000. 22 is promising, but we looked at all these ones earlier, you know, there's a bunch of crap. So let's find something really out of the ordinary in like the first 10,000, and then we'll go look at it and see if it's like actually promising or not. Okay, now we sit and wait. Well, oh wow, okay, this looks promising. See if there's any more. We'll go look at that in a second now. Okay, so now, well, I just commented out all my code for printing stuff, so okay, new plan. This is gonna be called variance robots. And we don't even want stream as a, yep. Okay, and we'll use that if we have to like look for more. And then we'll like, this does not need all this other stuff no more. We'll uncomment all that stuff out. This is trash. Okay, so can we like print robots? Okay, actual 8159. Yeah, that's it. Oh my god, we got it, you guys. We got it. Can't believe it. Oh, wow, it's a Christmas miracle. All right, well, there we go. I don't know why I didn't think about doing it that way in the first place. And you know what? I really would have been there for like a really long time if I tried to iterate through 8,100 different possible solutions. You know, I didn't expect this. You know, this was a tricky one. Everything else has just been like flip a bunch of things around. You know, like sort some lists, do some kind of nonsense. You know, play with a grid, count stuff in a grid. But this actually required like a little bit of thinking. You know, so it's a little tricky one, I guess. Anyways, till next time.